with that, we are actually going to start another session right now. It'll be 3 lightning talks, each for 10 minutes, and then we will save we'll have like an open question and answer period at the end of that 30-minute block. So with that being said, John.
Okay, great. Thanks, Chaz. Can I share? Can someone allow me to share my screen? It's saying.
You should be able to now.
Oh, here we go. That's going. Thank you. Let me find my slides. Yeah. So thanks for a great introduction, Chaz. I hope I live up to it. But yeah, I'd like to talk to you about today. Yeah. Well, thanks to the organisers of the track for allowing us to or allowing me to come and speak about this today. So this is our new project that it's so new, in fact, that the name is changing constantly, and we're now called Project BioBank. And this is something that we're working on with Thora Arn, our daughter, who is also at the conference. I think she's in the room today, and Jen Wright. And we're all based in Newcastle upon Tyne, as you can see, it's a lovely city in the picture there. And our shared purpose for this is to give access to biotechnology to people in northeast England and beyond in the rest of the UK for bioenthusiasts, school students, and local businesses that are working in harmony with microbes by building a community around an open biobank of safe microbial strains accessible to the public, and training on how to use and isolate and handle the microbes that are in there. So I'll tell you a little bit of a story about how I ended up doing this. So yeah, I'm John, and in 2013 I was really, really lucky to be involved in an iGEM team as an undergraduate. The top left picture there's, I've not seen that picture in such good resolution for that, so it's made me smile. Yeah, an iGEM team at University of Dundee. I super loved it. It was a transformative experience for me. I really loved, I was sort of inducted into this almost a cult of learning and making and sharing, and learn all about how to work in a lab and make things with bio, and then go and present and share that with the rest of the world. So I stayed in that lab to do a PhD, and I did supervised a few iGEM teams during that time as well, including these guys in the top right corner there. This is a high school team in 2016, and I was just incredibly proud of them. These guys had never stepped foot in a molecular biology lab in their life, and they did so incredibly well. And it really made me realize that all anybody needs to do biotech or anything really is just the access to the resources and materials for it, and some good teaching. So I'm finished with PhD now about a year ago, and I'm now working in the hub for biotech in the built environment. I'm based at Northumbria University. And we don't have an iGEM team yet, unfortunately, and I'm really missing that sort of culture of learning, making, and sharing with people. So I ended up, was really lucky, along with Chaz and some other people out here, I was in the Global Community Biofellows program, and it's really pushed me to try and make some more of this stuff happen in our area. And I spoke to Thora, who also works in the hub, and she's also an incredible bio designer who's part of the BioBabes group that you can see in the BioArt and BioDesign track today as well. And I said to her, Thora, like, what is there in the area here that for doing biotech? What is there that I can get involved in for doing some community bio stuff? And she said, well, unfortunately, there's not much going on around here at the moment. And she's had also experienced some difficulties with getting access to good information on how to start working with microbes and those kind of resources. And she really wanted to try and make that available to DIY bio designers to enable them to tinker with biomaterials and stuff. You see some of the pictures, stuff she worked on, it's awesome. So I was really excited about this. Felt like I've found a collaborator, someone that really shares some strong values with, and I was talking about this all the time. And as soon as I mentioned this to Jen, who's a really experienced microbiologist, who's been involved in facilitating microbiology teaching labs for years, she was like, I want to get involved in that as well. That sounds awesome. And she was really interested in trying to create resources or education resources for people that want to start using microbiology and get involved in microbiology. So we had a bit of a team, and we had worked out that there was poor access to resources. There wasn't much of a community around, and there wasn't good information resources on how to use any sort of practical resources you had in the first place. So we came up with a bit of a plan on how to solve that. We thought that maybe if we could build a biobank of strains to give people access to in a sort of open access way that could be populated by members of the same community. So we want to reach out to all the DIYers in our area and beyond the UK and the world to try and get them to populate with us an open access library of strains, microbial strains. And of course, you also need the good information to find out how to use them in your projects and get the most out of them. And as an iGEM person, I was immediately thinking of the registry of biological parts in iGEM, where you've got a page where your DNA sequence for the part, you've got all this standardized documentation on what it's supposed to do, how to use it, and some protocols on how to get it to do that stuff, and maybe even some data that someone else has produced on using that specific part. Also think about open wetware there as well, because I use that all the time for finding buffer recipes that I've not written down and can't remember and stuff. And then we can sort of leverage these resources to start building community as well by running workshops and mixers and things around that, where we can run some workshops with people that aren't already inducted into this cult that I keep on mentioning, learning, making, and sharing with bio by doing some workshops to tell them how to isolate strains and things that they find useful, maybe from beers or stuff like that, or cheese. And we can also get our community members to give us some work, to lead some workshops on projects that you can do with the strains that they've deposited in the biobank. Really start building capacity, hopefully, in that way. So I was thinking about this one lovely summer evening in Newcastle on my balcony, drinking some of my delicious kombucha. Sometimes delicious, sometimes not so much. And I was thinking, if I wanted to deposit this is so good. If I wanted to deposit this in the biobank, how could I do that? I thought, well, as a sort of academic microbiologist, I'm thinking, well, you've got to get a pure culture, you've got to isolate that, you've got to get it in a glycerol stock in a -80 freezer, don't you? And maybe Project BioBank could give you could sell a kit to enable you to do that and run workshops, like I mentioned, to sort of teach people to do that live via Zoom, maybe during pandemic. But of course, kombucha is useful on its own anyway. We don't need to get pure cultures, right? You can inoculate that straight away. So you send us raw kombucha or a piece of SCOBY or something like that. But once it's at Project BioBank, we've got a responsibility, obviously, to make sure that that is what you tell us it is, and also that it's safe. So what we would do is we would do some sort of rudimentary Sanger sequencing to find, so looking for the 16S sequence or ITS sequence for fungi or whatever is most appropriate for the strains that you send us to find out exactly what it is. Now, for safety reasons, we want to make sure that we're only using BSL-1 organisms in here. So if your strain was to come back as being BSL-2 or above, it wouldn't go in the bank. And the reason for this is just partly because it's more difficult in the UK to be sending and sharing strains that are sort of this risk level. And also we don't want to be responsible for anybody getting sick as well, or the escape of any strains that might cause someone else to get sick that's totally not connected with it. We'd have this policy as well for agents of ecological destruction, like plant pathogens and things too. That's really important. But if your strain is BSL-1, like hopefully most of them are, then they're going in the bank. To go along with your, yeah, man.
Sorry, I just wanted to let you know you have 1 minute.
1 minute, seriously?
Yeah, time is fine.
Oh man, okay. So we also want to know about, how do you grow these organisms? Really good information about how to grow them, but also really good information on what does it do. If you want to get that strains out, you could be sure that it was safe, reliably what it said it is, and access all that information to get the most out of it. We'd ask for a small fee to cover the costs of supporting the project and supporting the biobank and stuff. And if you did give us a strain, you would also get access to a strain credit to get a strain back for free if you deposited one. Okay, so what's next for the project? We want to hear from you, really, to find out how to run it best to serve that community. So we would really love it if you could get in touch with us to find out what info you need to make the most of it, what strains you might like to see in biobank. Is there one that you really want access to, or you think everyone should have access to? And of course, what strains do you have to share with us? So you can contact us on that email address there, projectbiobank@gmail.com, and we're also on Twitter and Instagram at Project BioBank. We also have a little form that you can fill out to end up on our mailing list, and we can get some more info on that from you as well. Thanks a lot, everybody.
John, thank you for the great lightning talk. And it looks like Thora actually shared that form in the chat. So yeah, you check out the form. Next, we have Rob from BioBus, who will be talking about using 3D printing to build microscopes and understand vision. Rob, I'm very excited to have you.
Awesome, thanks. Hi, Chaz. Hi, everybody. I'm really glad to be here. This is my first Bio Summit, and I've been having a great time so far, so I'm really thrilled with everyone I'm meeting and the conversations we're having. I look forward to more of that, and already looking forward to next year. So what I wanted to do is share this. Hopefully everyone's seeing, this is a 3D printed DIY microscope. There are a bunch of microscopes like this, I would say, in the world generally. There are platforms where you can 3D print things. Obviously, we know about the fold scope and cheap microscopes. What I want to talk about is how this microscope can be used as a teaching tool and how we do that at BioBus, which is where I work. And so that's going to be the focus of today's chat. So really quickly, if you don't know about BioBus, where I work, we're a New York City-based nonprofit. We want to make science free and accessible for everyone, and we want it to be fun. So we are an education-based group. We really work with students and schools primarily. We have 2 mobile labs that drive around the city. Typically, we visit schools with a bus full of microscopes. We let students have hands-on experiences. We have formed 2, and hopefully soon more, like brick and mortar biobases where students can come for hands-on science experiences. In all of those spaces, students have been using these 3D printed microscopes among other microscopes that we use. So the company itself is 12 years old, which is kind of hard to think about. Our community labs have been running since 2014, and we've actually been virtual since March. So we've taken all of our programs and converted them, and I have one of the microscopes in my apartment now. And sneaky plug, if you want to go to our website, biobus.org, you can see all the free virtual programs that we have to offer. But I want to talk about just the one today, which is the DIY microscope. And so this is a project that's been kind of incubating at BioBus for a little while. And these are the words that people who have used it, our staff and students, kind of in a word diagram or a brain map. This is what we think this project is supposed to be. It's a teaching tool for students to learn, and the same way it's a stepping stone into the sciences. It demystifies and empowers students by not being a black box, not just being a magnifying machine, but by being something that students can change and improve and modify. So they learn by making. We think it frees the inner engineer. I really like that. There's this tinkerer inside every student that just needs to be given the proper tools to take things apart. And most of all, it's fun. So you've seen pictures like this. I've actually got one right here. It's a neat little microscope, fits on a rail. There's a light source that we provide with it. And we'll talk about kind of what this microscope can do and how it magnifies and why I think this is so powerful a teaching tool. So credit to this project. It is the brainchild of Dr. Francesca Anselmi, who's a BioBus scientist. She worked on it with Josh Sanders, who's a mechanical engineer, who designed this kind of first model. And if you lay it out, if you're familiar with microscopes, it lays out very similar to a compound microscope. There's kind of the magnifying lenses on the right here and an optical train, very similar to compound microscopes. On the left is the light side, focusing the light, a sample, and then the configuration that is schematized here is just with a focusing lens and then a camera. We run into Raspberry Pi, but there are a few different ways to kind of get a picture out of it, including just an analog screen. So students can in real time see what they're magnifying by projecting it onto a sheet of paper or by putting it into an eyepiece and looking. What's cool about this project is that it's a platform that can be changed. So by changing the tube and objective lenses, you can change the magnifications. By changing the light sources, you can change the type of samples that you can see, and all of that just pops on and off the rail pretty easily. So the best thing for students is that it's phone friendly. We have a little piece that you can line your phone up to and just kind of make sure the camera looks down the optical path. And on that, you can image kind of right off the bat things on the millimeter and sub-millimeter scale. So blades of grass, Daphnia magna, small pond crustaceans. So you can orient it that living creatures can be imaged in real time. If you swap out the lenses for higher objective or kind of higher magnification tube lens arrangements, you can actually see cells. You can watch leaf cells of small plants or even brain cells that are cut on a cryostat from labs. So using prepared samples, we have cellular resolution and high magnification with the right setup on the microscope. This has been really cool for students. So BioBus has employed probably almost 100 high school interns in our existence to do independent research projects. And two of our first interns, this is Naomi and Zoe, as they modified the microscope to have fluorescent capability. So substituting in a blue light source and putting in a green color filter, they're actually able to look at this. This is a GFP mutated fly larva that was unceremoniously squished onto a slide. But we could actually make out all of the central nervous system and segmented nerves in this little cutout here. So this is a phone image taken by our students using this microscope. So both of them, hard to believe, they're both in college now. But Zoe continued on this project for another year where she was actually working with infrared light. So she swapped out the blue light source, or the blue light source with an infrared light source. And by doing that, she removed a lot of the kind of full spectrum chromatic aberration and increased her resolution. So really nice neuron images here from some slides that were prepared by a laboratory that we collaborate with. And a Daphnia magna's eye as well comes out really nice in this narrow band microscope. So Zoe took the microscope and ran with it in one direction for her projects. Another intern, or a pair of interns that worked on this, were Francesca Sodu and Charlene Adame. And what they did was they wanted to use it as a teaching tool. And this is actually what sparked this whole talk. So they wanted to see, how does the eye work? And can you do that with this microscope? So using the natural lenses of the eye as a model, the cornea, which has some light bending properties, and the crystalline lens on the inside, and then a retina, which acts as a screen, we laid out the same components on a rail, and they were able to basically modify an eye. And that was great. And then the next question was, well, what does the eye do? How can you teach with this? So they developed a quick video that shows if you use basically one curvature lens, you can focus on objects far away. A different curvature lens will help you focus on nearby objects. And they showed basically the way that your crystalline lens will change while viewing objects at different focal distances. Continuing in that project, what they want to do is study vision and visual defects. Now, another group saw that, and two interns named Addison Lev and Nico Bustamante worked with us, and they said, that's cool, but we want it to look more like an eye. So they made this project where they scaled it up, put it in a huge kind of chandelier orb. They really wanted the iris that could actually do pupillary dilation. So they went out of their way to make that work. And they created a full, like, large scale eye model, which Addison actually here is teaching a high school class how it works and modeling the eye so that other students can then use the 3D printed microscopes to recreate the components of. So this is, again, using the same rail and, like, obviously much bigger 3D printed pieces, but this project has kind of taken on a life of its own, becoming a way to teach about vision and the optics of the eye. So some threads that other groups are going to follow in the future, basically designing parts that can accommodate real microscopes. So I could pop the objective lens out of a commercial grade microscope, put it on the rail and still have it magnify, because it works the same way. Improving the Raspberry Pi compatibility, maybe even with feedback that can help us with autofocusing or focus suggestions. And then increasing the number of diseases that we can mimic. So interns have already made ways of showing how macular degeneration functions and what you can do to actually treat macular degeneration. And so there's a list of eye diseases that could be modeled using this.
Hey, Rob, just wanted to let you know we only have about 30 seconds left.
Okay, perfect. So yeah, the last thing I'll say is that we really want to get this into classrooms. We've been using it in grades 5 through 12. So here are high school students that are dissecting an eye with the DIY microscopes kind of at the ready. We do the same thing with 5th graders, talking about different points. But in the past, students came to our lab. We also send the microscopes out to classrooms, and we maintain a library in West Harlem so that students can get their hands on these microscopes. So if this interests you, feel free to email at diy@biobus or rob@biobus.org. Check out our website, and I'd love to talk to anyone who wants to work in this or has experience with this and kind of collab.
Wow, Rob, that was incredible. And I mean, it's going on in my backyard. I'm also in New York. This is so exciting. I mean, I would love to go visit the lab after COVID is taken care of.
Absolutely.
Yeah. So if you guys have questions, please keep them for later or drop them in the chat. Next, we will actually have Frazier, I believe, as he talks about implants in the near future. Frazier, are you here and ready to roll?
Yeah, I'm here.
Okay. Are you all set?
Yeah. Hey, everyone. All right. Just going to share the screen there. Okay. So today I'm going to be talking about implants, implants in the near term. And so what that means is just implants that are, have been made within the last 1 or 2 years, kind of the design and the formation of them, and kind of where they're heading towards and where they're probably going to head towards in the future. So my group that I'm part of is called Augmentation Limitless, and we actually make biocompatible coatings for implantable jewelry, we call it. So you see in the slideshow here, I just have a couple of pictures of some of the things that we work with, and I actually have some samples with me here. So these are just some real quick pictures of some little, what we call augment jewelry or implantable jewelry that we make. So on the left here, we have these 2 magnets set into this little hexagonal plastic shape with an NFC chip in the middle. And then to the right, we have, we have multiple little magnet implants. They're just set into this biosafe resin that are meant to be implanted into the finger. And our designs have kind of shifted from these larger implants to much smaller ones. So like, I don't know if you can really see this, but I'm holding one of the white implants in the lower right-hand corner of the picture there. We call these little things like a milk tooth, and it has a little magnet in the base here. And then that square thing in the top is an NFC chip. And it's shaped kind of rounded out, so that way it's meant for easy implantation into the skin or into the finger, for instance. And so a lot of people, often wonder, well, why would you get something like this in you? What's the purpose? What's the functionality? And the purpose is specifically with magnet implants, so that way you can sense electromagnetic fields around you. And that's part of the reason why you would put it in your finger, because you have dense nerve clusters in your finger. And, if you go through like say a metal detector or you pick up an object, you can actually feel the electromagnetic waves, through your nerves. So you have a little bit of extrasensory perception going on here with these little implanted magnets. And the little NFC chips are just so that way you can store just, a little bit of data. They can make a little noise if you power them on. All you need to use to power them on is a little like NFC reader on your phone. So it's a cool little trick. You have a little more extrasensory perception, and it's kind of a show-offy piece. You can show other people, that you can do this little thing with your fingers here. But kind of moving on to a bit more serious implants. So this next slide here is actually what's called a PegLeg. And what it is essentially is it's a local area network router that's been stripped down to its just most basic bare bones components. It's coated in this biosafe resin that's UV cured. You can see it's in a UV lamp right here. And once fully cured and all the edges are kind of smoothed out and it's polished up and it looks real pretty, then we implant it, usually somewhere in the leg. This is a very large one. This was the first one we ever did. We've gotten them down to a lot smaller size now. So we got them down to about the size of like half of the size of a credit card, for instance. And so it's not just so big and cumbersome. And of course, as you know, with the shrinking size of storage devices, you could potentially store up to, say, like a terabyte of data on this router that you have on your person that can then connect to other devices. So you can, and it's charged by induction. This is induction charging. So, inductively charged local area network router to interface with other devices and store data on your person internally. Why would you want this? I mean, if you, want to keep your data extra secured, or, if you want to have something extra flashy, this is definitely the thing to go for, I would say. And also in terms of flashiness and extra sensory perception, we've been working on things like this, which is like an NFC circuit hooked up to some LEDs. We've also thought about hooking up an NFC circuit to like some springs, so that way when you power on the NFC, you get a little vibration going on in the spring there, so you have a little feedback, so when that implant has been turned on. And people that like implants would certainly enjoy something that has that little extra sensory kick to it. So moving on from these more cosmetic implants, there's more serious like medical device implants. So I know the image is a bit grainy, but this is an implant for diabetes monitoring that a company recently started developing about 2 years ago. And it's a little subcutaneous sensor that actually monitors your blood glucose levels in real time. And it's meant to interface with this transmitter / insulin pump that you wear over your skin. And so that way you're able to, this machine like adjusts your blood glucose and your insulin boluses for you. And you can also do this via a mobile application. But since I'm talking about implants in the near term and what's coming up, instead of using something like a mobile interface, this next implant could get rid of mobile interfaces or even computer interfaces entirely. So this is, of course, the Neuralink. So you might be somewhat familiar with it. It's developed by, the Link is actually the product name. It's developed by a company called the Neuralink. And it's essentially a little, about a coin-sized like microprocessor that links directly into your brain. And they're actually going to use a robot to insert these threads directly into the cortical surface of your brain, and it'll receive these neuron synapse firings, and it'll convert that into data such that you could potentially use like a mouse or a phone or a computer just by thinking about it. So some of their first usage applications, they want to use it with people that are like paraplegics or quadriplegics, so that way they can remotely use devices, like computers or phones, for instance. They're actually developing an app for it, where you can just interface with your phone directly from your brain. And of course, they want to make this more mainstream. So eventually what they want to have is you be able to come in, sit down, get this implanted in your skull by this robot in the same day, maybe with no anesthesia, and then you can walk out and then you can interface with all of these different devices. So you can interface with this big storage unit, this PegLeg maybe that you have in your leg. You can interface with the NFC chips that are in your finger. You can interface with your glucose monitor you have on your arm. So what I'm trying to get at is that you will cease to have like external computers or external phones that you interact with. With all these different implantable devices, I could see you becoming, more like a computer yourself. In essence, you'll have the storage capacity, you'll have the memory, you'll have the interface directly into you. And I think, these devices kind of show that that's where we might be heading. And, if you've also heard about,
Hey,
and then that's just a
Frazier,
picture of the rope.
sorry, just 30 seconds.
Okay, cool. Yeah, so the main thesis of this is that with these implants, I can see us becoming, more, I guess, like computers ourselves, and being able to store data even, on our brain or on a chip that's connected to our brain, and using, our body more as a computer instead of these external elements. And also at Augmentation Limitless, we like to prove to people that, you don't need to have all this fancy lab equipment to make biocompatible materials, essentially. So that's what we're trying to do with our facility here.
All right. Well, thank you, Frazier. Very incredible talk, and I don't know if you were seeing the chats coming in, but we're seeing the chats coming in. Sorry, I think there was just like some feedback, but there were a lot of really great chats related to your talk and a lot of questions. And that actually, leads us to our Q&A period right now for the previous 3 talks with John, Robin, yourself, Frazier. And so if anyone has any questions for any of the speakers that we just had, please feel free to drop them in the chat. I had a question that I would like to just propose to anyone who's willing to answer it, of the 3 speakers. How has this pandemic really affected the work that you're doing? And I think it's a bit more obvious in some cases, but maybe not so obvious in others.
It hasn't affected us a ton or that much, to be honest with you, because we're just kind of starting out. So we don't have like a ton of, orders to fill. We don't have a ton of demand for our products. We're just producing demo pieces. So it actually kind of gives us some more time to like experiment with things. And we're really in no rush to kind of push things out. Although we definitely want to have like some kind of product line so that we can fund ourselves, in the future here.
Yeah, I'll say that maybe one of the interesting things that happened with 3D printing was a lot of 3D printers in New York went into producing PPE. So ours actually got enrolled in another project altogether, which was cool. But we stopped making things. We started thinking about how to support programs virtually with our microscopes, and yeah, it's been kind of a slow period because there's the idea of a library, like taking something, borrowing it, handling it, and giving it back is not super popular right now either. So it's been a time to reflect and kind of maybe upgrade some things we've been meaning to fix up, but it's been a little slow.
Yeah, I agree with Rob about thinking about changing to virtual and stuff. I think when we were discussing how we would try and make something like this early on, it kind of, some of the activities that we're thinking about doing were obviously things like, oh, we'll get everyone in a room together and do some microbiology. Obviously, it's not possible at the moment. So some of the things that we're thinking about now is preparing kits, like I mentioned, for people to buy at sort of more or less just cost of the materials. And we can send them out and then do a workshop with people virtually on whatever it is that that we would do with the kit that we would prepare.
Wow, thank you guys. All very interesting responses, and yeah, it definitely has affected a lot of us in ways both kind of we would assume it would affect us, but in ways that we just like couldn't imagine. David from the Open Science Network had a question earlier during Frazier's talk that I saw that I don't think was addressed. And I don't know if we can unmute David to ask about the composition, but if so, maybe we can have him just ask the question directly.
People should be able to unmute.
Or, and David, if you want, I can just ask the question. Which was to Frazier, what is that bioresin that you talked about? What is the composition of it? It's a question I definitely had.
Yeah, so it's dental bioresin, actually. So it's polymethyl methacrylate, and also, what is it? Oh yeah, paliseal is what we're using over here. So yeah, so we use those coatings, and they're unique, durable coatings that go on hard, and totally biocompatible. They're actually used for dental procedures, so like to make dentures or false teeth. So yeah, all you really need are just those. They sell them, usually to dental offices, but you can just buy them and just get a UV lamp, and then that's essentially it for that.
Very cool. There were a couple follow-up questions. One from Nini. How long would an implant last with that material?
It really kind of, I don't know, it really kind of depends. Potentially, I mean, the rest of your life. But yeah, at least like several years, or multiple consecutive years. But yeah, it should, if there's no like physical damage to the implant itself, it should just remain within your body, just kind of inert. So for a very long time period, so it could be decades, potentially. So yeah.
Nice. John also asked, what's the process for sterilizing?
For sterilizing it, so through the UV curing process, that kind of sterilizes it in and of itself. We also wash it in an alcohol bath to kind of sterilize this. So yeah, there's also other, like just chemical. So yeah, like UV taper a lot, and then just alcohol, sterilization, ethanol. So that's what they use a lot in like cell culture hoods. It's a UV ethanol combo there. So yeah.
Very cool. We have a question from Adrian to John, actually. Is there a list of the items in the biobank?
Thanks, Adrian. Not yet, but there will be soon. If you fill out that little form, I can put the link in again. You can get updated as soon as there is one to see. Sorry.
Okay, and we have about 2 more minutes left in this session. If there are any final questions, we can probably answer maybe 1 or 2 questions. If not, we can continue the conversations definitely online on Slack, maybe offline post shutdowns. Oh, there was a question. Have you considered this device for Alzheimer's patients? And I assume that's for Frazier.
What was that?
It looks like the question is, have you considered this device for Alzheimer's patients?
Which device? The like the Neuralink, or so like with something like the Neuralink, they only have access to the cortical surface, which deals a lot with your like motion and motor functions, but they do want to go deeper down into the brain and treat other disorders like behavioral disorders and potentially also memory disorders. So I mean, what you could do in their like expose conference, they talked about potentially storing memories directly onto the device. So, that might be, I guess, somewhat of a workaround for Alzheimer's. I'm not so sure about, if they could fix the actual deterioration of the brain, but just as a rough storage unit, I think it has potential there.
Okay, thank you. I think this session was really, really quite interesting and touched on a lot of aspects of science